To start this chapter, we're going to be looking at identifying linear functions. A function whose graph forms a straight line is called a linear function. So let's identify whether between these three graphs, which one represents a function and if the function is linear. So here we have three graphs. The first one we see is just a line. This is going to be the second graph. And our third graph. Okay, now let's look at that first graph. Each domain value is paired with exactly one range value. That basically means each x value is paired with one y value. So the graph forms a line. This is a function, and it's a linear function. As you can see, we did the vertical line test to test it, and it only intersects at one point. A linear function is a straight line and a function. This graph has both of these qualities. Now we're going to look at the second one. We can see that it's a curved graph. When we do the vertical line test, we see that it only intersects at one point. So we know it's a function, but it is not a linear function because it is curved. Linear basically means straight. Now let's look at the final graph. The only domain value, 3, is paired with many different range values. So basically, one x value has many y values, so this is not a function. Okay, now we're going to look at identifying a linear function by using ordered pairs. So here we have some ordered pairs. We have 2, 4, 5, 3, 8, 2, and 11, 1. We're going to put them in a table of x and y's. Alright, now we're going to look at the difference between each x value. When we go from 2 to 5, there's an increase of 3, so we can put a plus 3. When we go to 5 to 8, there's an increase of plus 3 again. When we go from 8 to 11, there's also an increase of plus 3. Now let's look at the differences between the y values. When we go between 4 and 3, there's a subtraction of 1, so that's a minus 1. When we go from 3 to 2, there's another subtraction of 1, so that's a minus 1. And we go from 2 to 1, there's also a minus 1. We can see that there's a constant change on the x values of plus 3, and there's a constant change of minus 1 in the y values. Because there is a constant change in both the x and the y values, these points satisfy a linear function. It's linear because of the constant change between the x and y values, and it's a function because each domain value has exactly one range value. A linear function is an equation that can be written in standard form. Standard form is ax plus by equals c, where a, b, and c are real numbers, and a and b are not 0. So to show a real-life example of this, we have 3x plus 2y equals 10. This equation is written in standard form. Now we're going to show you a couple examples of standard form that's not linear. Here we have 3xy plus x equals 1. This equation is not linear because x and y are being multiplied, and this is not something that fits into standard form. Okay, now we have x plus 6 over y equals 12. This equation is not linear because y is in a denominator. Now we're going to look at the final example. We have y equals x squared, and we want to determine whether it's a linear function. And we can immediately tell this is not linear because x has an exponent other than 1. So when the variable has an exponent other than 1, the equation is not going to be linear.